Good morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department, Chibrol Engineering College. Today also we are going to discuss about some more examples in the Laplace transformation. So yesterday we discussed some examples in graphical representation and the mathematical expression values. Now, there's some more few examples we have to go for the discussion in this session also. Is the first one. You can see the x of t is equal to e power minus 4 magnitude of t. X of t is equal to e power minus 4 magnitude of t. This magnitude depends upon the greater than or equal to 0 and the less than or equal to 0. Greater than or equal to 0, the t value is a positive. T value is a positive. So the x signal e power minus 480 will get the negative exponential. And t is less than or equal to 0. The exponential is will get the positive exponential because the t is minus. Already we have the minus is there. Minus into minus is a plus. So within the range of minus infinite to infinite, you can split the two parts minus infinite to 0. The given x of t signal is a positive exponential e power 4t into e power minus st dt according to the definition of Laplace transformation. And the second part, the 0 to infinite, is a positive real axis. In that, x of t is a e power minus 4t with the definition of Laplace transformation e power minus st dt. So e power, take the minus as a common, s minus 4 into t dt. And in the second second term, e power minus, you can take the s plus 4 into t dt. The e power minus of s minus 4 into t, apply the integral with the limitations of minus infinite to 0, e power minus s minus 4 into t by minus s minus 4. Second integral also, e power minus s plus 4 into t by minus of s plus 4. The upper limit is infinite and lower limit is 0 here. Substitute the upper limit for the first term. You'll get e power 0 is a 1. And denominator is a minus 1 by s minus 4. And second term is a 0. If the term is a 0, we'll get. And the third term also, the first upper limit in the second term is a 0. That is also 0 we'll get. And in the denominator, the minus already there. For the second lower limit, you can substitute minus into minus becomes a plus 1 by s plus 4. So minus 1 by s minus 4 plus 1 by s plus 4. Only the two functions we have. Minus 1 by s plus 4 plus 1 by s, not the s plus 4, my dear students. Here it is a minus plus 1 by s plus 4. The remaining two functions, whatever we have, it is a 0 because the infinite and infinite is there, is a 0. Okay. So take the LCM is s square minus 4 square minus of s plus 4 and plus s minus 4. Okay. Minuses and minuses get cancelled, and the minus 4 and the minus 4 we have. It becomes of minus 8 by s square minus 4 square. Minus 8 by s square minus 4 square. Okay. After the simplification, you get the c minus 8 by s square minus 4 square is a 16. So with ROC of all the points, as all points in S plane in between the lines passing through the sigma is minus 4 and the sigma is a plus 4. Why it is s square is equal to 16 means s square is equal to s square minus 4 square is in between the values. I can't say that is a greater than or equal to, or it is a greater than or equal to. You can see S square is equal to 16 and S is equal to plus or minus under root of 16 and S is equal to plus or minus 4. So it starts from the above value of minus 4 and the below value of the 6, 4. So in between the range of minus 4 to above the minus 4 and below the plus 4. Okay. So the overlapping in between, say above minus 4 means up to the infinite. Below the plus 4 means up to the minus infinite. The overlapping is occurs in between of minus 4 and the 4 only. Minus 4 and the 4. So ROC is in the range of minus 4 to the plus 4. Okay. With these values only, in between of these minus 4 to the 4 values only, the Laplace transformation exists. The remaining always values, it is not exist. It is not a bounded. Only it is a bounded in between of minus 4 to the 4. The ROC is S is equal to plus or minus 4. S is equal to plus or minus 4. Coming to the next one, my dear students. So determine the Laplace transformation of the following signals. One is a sine omega naught t mu of t. We've already seen that the sine omega naught t mu of t. Sine omega naught means in terms of the exponential e power j omega naught t minus e power minus j omega naught t by 2j. This is x of t the given. And the definition of Laplace transformation e power minus st dt with the 0 to infinite y it is means it is multiplied with the mu of t. So 1 by 2j you can take the common e power j omega naught t e power minus st. Take 1 by s minus j omega naught minus 1 by s plus j omega naught. After the simplifying this, the Laplace transformation of the sine omega naught t is omega naught by s. The Laplace transformation of the sine. If the Laplace transformation of the cosine is a s by s square plus omega naught square. Cos omega naught t mu of t. Okay. You see the cos omega naught t mu of t. You get s by s square plus omega naught square. Because what is a cos omega naught t exponential according to the Euler's identity e power j omega naught t plus e power minus j omega naught t by 2. Okay. Substitute in the definition of the Laplace transformation, you get 1 by s minus j omega naught plus 1 by s plus j omega naught. Now you can simplify the s square minus j omega naught whole square. J square is a minus 1. So s square plus omega naught square and s plus j omega naught in the numerator plus s minus j omega naught. Imaginary term get cancels. 2s and 2 to get cancelled, we'll get only the numerator is a s. So s by s square plus omega naught square. S by s square plus omega naught square. Remember here, whenever we will get the cos, s is in the numerator. Whenever we will get in the sine, omega naught is a nothing but the constant value. S square plus a square simply. Sine 80, cos 80. A value is a constant there. And the s value is whenever it is a cos. Sine means omega naught or it is a. Similarly, the x of t is a cos hyperbolic omega naught t. What is the difference of cos hyperbolic and cos omega naught t in the Euler's rule? There is no any j terms there. So x plus e power minus jx by 2. But in the cos hyperbolic x value, e power x plus e power minus x by 2. There is no e power jx plus e power minus jx. Got it, my friends? There is no any imaginary term in the cos hyperbolic omega naught t where we can write as in the exponential values. E power j theta plus e power minus j theta by 2. Got it? Now we can simplify this function. Take it as finally 1 by s minus j omega naught plus 1 by s plus omega naught. So previously there is a j and here also the j is there. S square minus omega naught square Previously, if it is a j square, becomes of minus and minus plus s by s square minus omega naught square. Similarly, for the sine hyperbolic also, sine hyperbolic theta is there. That will get the omega naught by s square minus omega naught square. And coming to the ninth one here, e power minus at sine omega naught t mu of t. E power minus at sine omega naught t mu of t. Here there is an extra added the signal e power minus at. I will explain here. E power minus at mu of t, Laplace transformation, we know that is 1 by s plus e, s plus e. Now sine omega naught t mu of t, Laplace transformation is, I told you it is a sine means the numerator is a constant omega naught s square plus omega naught square. Now we are combining these two signals, e power minus at sine omega naught t into mu of t. So why it is a mu of t means it is a positive real axis and it is also positive real axis. After combining the two functions, e power minus at sine omega t is also the positive real axis. Where is in the positive real axis? Laplace transformation. E power minus it is a s plus e. So wherever the s is there in this term, you can replace that as s plus a whole square. S with s plus a whole square plus omega naught square. Simple way. You see, you got the same thing, omega naught by s square, s plus a whole square plus omega naught square. Now you can see the simplification, whether you are getting the same answer or not. Integral 0 to infinite. I'm substituting the mu of t is a 1, e power minus at sine omega naught t, e power minus st dt. What is the sine omega naught t? E power j omega naught t minus e power minus j omega naught t by 2j. Okay, take the 2j is outside, and e power minus at, e power j omega naught t, and e power minus st. The three terms we have as a base is the same. You can add all the terms. Take the minus, s plus a minus j omega naught t dt. And here the in between the minus is there the second integral. Here also the three terms, e power minus at, e power minus j omega naught t, e power minus st. Take the minus as a common, s plus a plus j omega naught t dt. Okay, apply the integral for the first term, e power minus of s plus a minus j omega naught t dt, whole divided by the total coefficient of the t is minus of s plus a minus j omega naught, with upper limit is infinite and lower limit is 0, minus e power minus of for the second term is also apply the integral e power minus of s plus a plus j omega naught t. The coefficient of the t you can write in the denominator, minus of s plus a plus j omega naught. Upper limit is infinite and lower limit is 0. So now I can substitute upper limit, the value is 0 here. E power 0 is 1. So 1 by s plus a minus j omega naught. And third term is also 0. When you can substitute upper limit in the second term. The lower limit is 0 here. E power 0 is 1. So it is a minus 1 by s plus a plus j omega. Now you can take the s plus a as a single term. It is in the form of a minus j, b, a plus b. So a square plus b square. What is a here? S plus a whole square minus j omega naught whole square. J square is a minus and the plus. And the numerator s plus a plus j omega naught minus s minus a plus j omega. So minus s plus s will get cancelled, a will get cancelled, and the denominator is s plus a whole square plus omega naught square. Okay, in the numerator you can see that j omega naught and j omega naught is a 2j omega. Here already we have one 2j get cancelled, omega naught by s plus a whole square plus omega naught square. So finally we get omega naught by s plus a whole square plus omega naught square. Similarly, for the second example here, see the 10th one, e power minus at cos omega naught. So what is a cos omega naught t? Cos omega naught t mu of t. The Laplace transformation is s by s square plus omega naught square. Okay. Now the e power at mu of t is a 1 by s plus c. So replace s wherever the s is there, s plus c. That one. So e power minus at cos omega naught t mu of t. What is the Laplace transformation? Without the s, we have to substitute s plus a by s plus a whole square plus omega naught square. What did my test? The same thing. S plus a by s plus a whole square plus omega naught square. You can remember these two Laplace transformation. Definitely can write out directly the e power minus t cos omega naught t and e power minus at sine omega naught t Laplace transformations. So actually these are all the bits only, my students. How to remember? Okay. If suppose it is a e power plus at, e power plus at means 1 by s minus a. This becomes of s minus a. What is the e power plus at cos means s minus a by s minus a whole square. And similarly here also omega naught by s minus a whole square plus omega naught square. Got it? We already seen this graphical representation, my students. Determine the Laplace transformation of the signal 0 to t by 2 and 0 to a and the ramp function 0 to a value, the 0, 0, and here it is a comma a. Is already seen. And coming to the 14th one. 14th one, we did up to these three. The first one, determine the Laplace transformation of the following, and for the second gated function, and the 13th one is a ramp function. And the 14th one, you can see the ramp function is in the reverse direction. Okay, so what is the quadrants? You can see the quadrants at this point is a 0, 1. So x1, y1 is a 0, 1, and x2, y2 is a 0, a, 0. Now, using the straight line equation, y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, this straight line equation y is equal to mx plus c. M is nothing but the slope. Y minus, what is the y1 here? 1 is equal to, what is the y there here? Y is nothing but x of t. Directly you can write this x of t. X of t minus 1. Y2. Y2 is nothing but the 0. 0 minus y1 is a 1. And x2 is a. X1 is a 0, and x value is a t because it's a varying of the t variables, minus x1 is a 0. So x of t minus 1 is equal to minus t by a, minus t by a, and x of t is equal to 1 minus t by a, 1 minus t by a in the range of 0 to a. Okay, 0 to a. And the remaining functions is a 0. You see the x of t is equal to 1 minus t by a for 0 to a and 0 for the remaining functions. So greater than the a, and in the less than the 0 also a1. I are not taking that less than means because it is multiplied the mu of t. So mu of t means always you can take the positive real axis only. Okay. Now, using this equation x of t, 1 minus t by a, 1 minus t by a is x of t, substituting the definition of the Laplace transformation with the limitations of 0 to a. You can split the two parts. 0 to a is 1 into e power minus st dt, and minus 0 to a t by a e power minus st dt. So e power minus st, the integral is e power minus st by minus s. The upper limit is a and lower limit is a 0, minus, and the 1 by a, you can take it as a common. 0 to a, the t into e power minus st dt. T into e power minus st dt, because it is applied by parts. Okay. For the first one, you can substitute the upper limit e power minus a into s by minus s, plus e power 0 is a 1 by s, and minus 1 by a. First of all, you can take the u as a t, apply the integral of v e power minus st by minus s, minus, take the derivative of v, not the v, u, 1, apply the integral of e power minus st by minus s. Again, you can apply the integral of e power minus st, that becomes of s square. Okay, e power minus st by s square. It is a by parts, my dear students. Then assume the t as u and e power minus st is a v. Take the v and apply the integral of v, minus the integral of derivative of t is 1, and the integral of e power minus st is e power minus st by minus s. Again, you can apply the integral of e power minus st. In that, you will get the minus s again in the denominator. Minus into minus is a plus s square. Okay, substitute the upper limit and the lower limit in these three terms, not the three, two terms. Already we have the two terms. E power minus as by minus s plus 1 by s minus 1 by a into 1 by a into, and multiplying the term a as a t, a into e power minus s into a by minus s, minus, because it is a minus t already there here, the minus into minus is a plus, a value e power minus s a by s square, and a is multiplied here, and the lower limit you can substitute. The first term is becomes a 0, second term is minus into minus is the plus, but because it is a lower limit, again we'll get the minus. E power minus 0 is a 0, 1 by a into s square. Okay, so e power minus a by s plus 1 by s, and a get cancelled, e power minus a is by minus s, minus into minus is becomes a plus. The two functions, minus e power minus s by s and the plus e power minus s by s, means these two get cancelled terms, and the second term, whatever we have, the 1 by s, and the fourth term is there, e power minus s by a into s square minus 1 by a into s square. The two terms is get cancelled here. 1 by s, e power minus as by as square minus 1 by as square. Take all the terms is a 1 by as square is a common. 1, here it is a 1 value, and in this also as square is take the common, e power minus as, and in this function we have only the 1 by s. Already we got it the as square. So multiply the a to get cancelled and multiply the s. So a into s. Got it, my dear students? Like that, the simplification only. After applying the, taking the x of t signal from the graphical representation, substitute that x of t and apply the integral and simplify. Finally, you get the 1 by as square into e power minus as plus as minus 1. Okay. Next, 15th one. Determine the Laplace transform of the sine pulse. Sine pulse. Actually, the sine wave means positive real axis and the negative real axis. varies from the 0 to pi and the 2 pi. The full cycle is a 2 pi, my dear students. We have only the positive half cycle only for the given x of t signal. There is no any negative half cycle. So what is the function? The x of t is equal to sine t in the range of 0 to pi and 0 for remaining values. Nothing but the t is greater than or equal to pi. Okay, because it is multiplied the mu of t also. Sine t mu of t. Only the half we are taking, the 0 to pi only. Now, I'm taking the 0 to pi, a as a magnitude, you can take here the a, and this one is a minus a, but there is no any half cycle here, positive negative half cycle, only the positive half cycle. 0 to pi, a into e power jt minus e power minus jt by 2j, because sine t is, according to the Euler's identity, e power minus st. Simplify this one. Okay, simplify. How we get e power jt into e power minus st? Take the minus is common, s minus j into t. And the denominator is a minus of s minus j, because the t is a coefficient here, minus a by 2j for the second term, and apply the e power minus jt into e power minus st. Take the minus as common, s plus j into t. And denominator is also, you get the s plus j with a minus, upper limit is pi and the lower limit is a 0. In the two terms, a by 2j is a common. A by 2j is a common, and the upper limit and the lower limit is also the same. So e power minus of s plus j, it is not the s plus, my dear students, it is a minus here. It is a minus of s minus j, and is a minus of s plus, is a s plus, my dear students. Not the plus, it is right only. Sorry, because it's a minus into minus, it becomes is a plus. So first term is the s plus j only, and the second term here the minus is there, so you can write it as a minus. Okay, is the right one. And now we can apply the upper limit and the lower limit in these two terms. A by 2j, upper limit, if I am substituting the as a t as a pi, e power minus, now I will simplify here, e power minus of s plus j into pi by s plus j minus e power minus of s minus, it is minus j into pi divided by s minus j, and the lower limit you can substitute, we get the minus e power 0 as a 1 by s plus j. For the second term here the minus is there, for lower limit you can substitute the minus, and minus into minus is a plus, 1 by s minus j. S minus j. Now we can simplify this term. What it? The denominator you can see the s plus j and s minus j only. S plus j and s minus j. S square minus of j square. J square is a minus, so it becomes of plus s square plus 1. Is s plus 1, s plus j. Now I am multiplying with s minus j into e power minus of s plus j into pi minus s minus j out there. So you get it is s plus j as a multiplication factor, e power minus of s minus j into pi minus, we have the s plus j, now we'll get the s minus j, so s minus and means plus j here and the remaining function s plus j, s minus j, you get s plus j plus s plus j. Okay, so plus s and the minus s get cancelled. Got it? Now, still we go for the simplification. S into e power minus s into pi, and the minus s into e power minus s j into pi. Both are to get cancelled. Is a plus s into e power minus s j into pi. So I will simplify that one. S into e power minus s into pi minus j into e power minus s into pi. After expanding these two terms and multiplying with the s, my dear students, j into e power minus s, and again you can take it as a plus s into e power minus j into pi minus j into e power minus j into pi. Okay, and again here minus s e power minus s into pi minus j e power minus s into pi, and the next terms minus s e power plus j into pi minus j e power plus j into pi, and we have the s and s get cancelled, the 2j is the numerator, and the denominator you can see s square plus 1. Now observe here s into e power minus s into pi. Okay, and here minus s into e power s into pi. Both are get cancelled. Then again, is there any terms is a common s into e power minus j pi here? But here it is a s into e power plus j pi. Okay, it is not the same. J into e power minus s, and here the minus j into e power minus j to pi. That is equal to here the minus and here the minus 2j e power minus s pi and plus e power j plus s j pi plus, and here also minus j minus j pi e power minus j pi minus j into e power minus s pi minus s into e power plus j pi minus j into e power j pi whole divided by s square plus 1. S square plus 1. And this totally is multiplied with a by 2j is there. A by 2j. Now still you can go for the simplification. E power minus j pi, and here the e power minus j pi is there. E power j pi, e power minus j pi, you can take. So after the simplification, we'll get minus j e power minus j e power minus s pi, and minus j e power minus s pi. Take it as a minus 2j e power s pi, and plus s e power minus j pi, and minus j e power minus j pi, and minus j e power s pi, and minus s plus j pi, and minus j e power j pi, and plus 2j is also there. Plus 2j, I forget this one, the plus 2j. Got it, my dear students? So in this, again, you can take the common as the terms a by 2j, a by 2j. See here the s e power minus j pi and j e power minus j pi. So these two terms, only the e power minus j pi is a common. E power minus j pi. So it becomes of s minus j, s minus j. Got it? And we'll get these two terms. And another here, the e power j pi and e power j pi plus, take the common, get the e power minus j pi. Take the minus as a common term, s plus j into, in these two terms, I am taking the e power j pi, positive j pi. So all we got 1, 2, and 3, 4 will cancel there. And we have the e power minus s pi, and e power minus s pi is a common here. Take that also common, minus 2j here, and here the minus j. So total is a minus 3j, minus 3j, 3j into e power minus s pi, plus 2j. Further, you go for the simplification, you can find out the e power minus j pi and e power plus j pi. What is the e power plus j, e power minus j pi? E power minus j pi means cos pi minus j sine pi. Got it, my dear students? Sine pi. What is the cos pi? Minus 1. The sine pi is a 0. So the value of e power minus j pi is a minus 1. So what is the e power j pi? Is a plus 1. This value is a plus 1 and this value is a minus 1. You can simplify the minus 1 here. You can substitute it as a minus 1. And this one is a plus 1. So minus means minus s plus j, and minus s minus plus j here. So you'll get minus s, and here the minus s, minus 2s, plus j is a plus 2j. Got it, my dear students? So further you go for the simplification. Whatever we got here, the same thing. Minus of s minus j plus s plus j here, and s plus j into e power minus 3 pi, and here the s pi, my dear students, and s minus j into e power minus s pi. I simplified these functions. We'll get a by 2j into s square plus 1, s square plus 1. In these two terms, minus s and the plus s to get cancelled. Minus into minus is a plus, plus j. And here the plus j, that is a 2j, will get in these two terms. Again here, you can write as is a e power pi, and that is a cos pi. Cos pi is multiplied with anything, you'll get it is a plus 1 something. So s minus minus s, and here the plus s is there. Both are get cancelled. And here the minus into minus is a plus j. And here also the plus j. You'll get the 2j into e power pi into s plus 2j. So what is the numerator here? A into 2j is the common. 2j also get cancelled. Numerator is e power pi into s plus 1. E power pi into s plus 1 by s square plus 1. Pi into s minus 2. What is the final answer? What we are having, it is a by s square plus 1. The 2j it get cancelled and take the common here. After that, it is a 1 plus e power pi into s. Is the final answer for the given waveform, the positive half cycle of sine wave. A by s square plus 1 into 1 plus e power pi into s. 1 plus e power pi into s. These are s, my dear students. Don't confuse it. It is not the 3 s. And here also the s. E power minus j pi, we can substitute as a minus 1. E power plus j pi is nothing but it is a plus 1. And here also e power j pi is a 0 here. It is e power 0 is a 1 and e power 0 is a 1. Then you can simplify this one. Got it? Next one, the given waveform is both having the two slopes are there. The two slopes. You can find out the Laplace transformation. Two slopes, Laplace transformation. One slope is with quadrants is a 0, 0. And another quadrant is the t by 2a. T by 2a. You can write that one. What are the quadrants here? First one is a 0, 0 for the slope. X1, Y1. And second with the range here, the t by 2 is the x value and y value is a. So x2, y2. This is in the range of 0 to t by 2, my dear students. T by 2 quadrants. Not the pi by 2, t by 2. Similarly, another quadrants for the range of t by 2 to t. What are the quadrants here? T by 2 into a is x1, y1, and x2, y2 is t comma 0. x2, y2 is t comma 0. The first you can find this slope. What is the slope here? y2 minus y is nothing but here. Let us say the y is the x of t. So x of t minus y1 is a 0 is equal to y2 is a minus y1 0 x2 t by 2 minus x1 is a 0 into x minus x1. What is the x here? The t minus x1 is a 0. So x of t is equal to a by t by 2. A by t by 2 into t. So you can simply now can write as x of t is equal to 2a by t into t. It's the same thing. You'll get for the first one 2a t by the 2 will get in the numerator. 2a by capital T is a constant and the t is a variable in the range of 0 to t by 2. For the second one, you can write by using these quadrants y, nothing but x of t minus y minus y1. What is the y1 here? It is a is equal to y2 is a 0 minus y1 is a, x2 is a t, minus x1 is a t by 2, and x minus x1, x is a t, x1 is a t by 2. Okay, so x of t minus a is equal to a by t minus t by 2 is a t by 2, and t minus a t by 2. Got it, my dear students? That is equal to x of t. Simplify this one by multiplying the functions. A you'll get in this one a plus now multiplying this a by 2a means 2a by capital T into small t minus, and these two will get cancels. These two will get cancelled and it becomes of a only, and here the minus into minus is a plus, the a, and a is get cancelled, 2a by t into t, and this is also will get the same, my dear students. But here we'll get the 2a minus 2a by 2. Why you got x minus x of t minus y1, y minus y1 is a is equal to y2 is a 0 minus y1 is a, x2 is a t minus t by 2, x2 minus x1. Okay, x2 minus x1. Then the t x minus x1 minus t by 2, and it is a t by 2 get cancelled, it is a minus a, and this becomes of a minus a, it is a minus a and the 2a by 2. Why you got this one? The slope is both are not the same because it's the quadrants are the different, and we can take this slope is started here, so can write it as this one is x1 and y1, and this can take x2 y2. I can find x of t minus nothing but y minus y1 as a 0, y minus y1 as a 0 is equal to y2 minus y2 is a minus y1 is a 0, and x2 is a t by 2 minus t, and the tx minus x1 is a capital T. Okay, so that it is x of t is equal to a by minus t by 2 into t minus t. That it is becomes of 2a by minus t into t, and minus it becomes is a plus 2a. This is the equation, my dear students. We got a minus 2a t by t and this plus 2a. So the range here, it is the values of quadrants is different. x1, y1, you can take it as a t comma 0, and x2, y2 is a t by 2a. So you'll get the 2a minus 2a by t into t. Okay, you got the two equations in the range. Two equations in the range. I can substitute in the definition of Laplace transformation. What is the Laplace transformation? X of s is equal to, in the integral of minus, not the minus, 0 to t by 2, x of t. What is x of t here? The 2a by t, capital T, and the small t, e power minus s t dt, plus another integral we have, that is a t by 2 the t, What is the x of t? The 2a minus 2a by t into t e power minus st dt. Got it, my students? So 2a by t is a common because it is a constant. 2a by t is a constant. And what is the Laplace transformation of t? 1 by s square. 1 by s square in the range of 0 to t by 2 here. The t into e power minus st dt. 1 by s square, the first term. Minus, and again here we'll get the 2a into e power minus st dt. 2a minus st dt, and it is a 2a by t into e power minus st dt. Here also there is a t term is there with the limitations. If I am taking the first term, you can write it as plus. For the second integral, we can simplify, that is a 2a, because there is no any term here, e power minus st dt. E power minus st dt is a e power minus st by minus s, because it is only the one value. With upper limit is a t, lower limit is a t by 2. For the second one, minus 2a by t, minus 2a by t, t into e power minus st dt. 2 into e power minus st dt. You can not directly write it as 1 by s square, because it is a t by 2 and the t is a limitations. So apply the by parts here for e power minus st dt. T into e power minus st by minus s minus e power minus st by s square with the limitations of t and the t by 2. And for this also, it is not the correct matter, students. For this also, you can write it as 2a by t. Here also you can apply the by parts limits. T into e power minus st by minus s minus e power minus st by s square with the limitations of 0 to t by 2. With the limitations of t by 2. Now you can apply all the terms. So I take here the 2a by t is a common, the t into e power minus st by parts with the limitations of t by 2 and 0. And here the two terms are there. I'm taking the first term, 2a into e power minus st dt, 2a and e power minus st integral with the limitations of t and t by 2. And second term, there is a minus 2a by t, t into e power minus st by minus s, and the by parts I applied is equal to substitute the t by 2 in this term, 2a by t, t by 2, e power minus s t by 2 by minus s minus e power minus s t by 2 by s square, and the 0, both are the minus here, it becomes as a plus, 0 and 1 by s square. Got it? And plus 2a. Now upper limit is t and the lower limit is t by 2. E power minus st minus e power minus st by 2 by minus s. And the third one we have the 2a by t simplified with the t and the t by 2. T e power minus st by minus s minus e power minus st by s square, and both are minus. The lower limit you can substitute the plus t by 2 e power minus s t by 2 by minus s, and here the minus is at plus e power minus s t by 2 by s square. Now I can simplify the terms. Here the 2a by t square by 2 e power minus s t, it becomes of minus is there. Is a minus term. Here the minus into minus, it becomes of the plus. So this term will get cancelled, these two, and this also. Here also the minus is there, but with this minus and minus, it becomes of a plus, the two terms, and the lower limit here. Here it is a s square as a minus, and this is a minus into minus, here the plus. It becomes get cancelled 1 by s square. After simplifying the terms here, we'll get the 2a by t s square by 1 minus e power minus st by s into s square minus whole square minus students. We simplify this term, we'll get definitely this one. This is in the form of a minus b whole square, a square plus b square minus 2ab. Let's simplify that one. We'll definitely get the term. The next one, the 17th here, some square wave is given. We don't know the range here. By using this graphical representation, first of all, you can write the signal x of t. What is the signal x of t from 0 to 1, the 2, 3, 4, and 5? The first range here, the 0 to t. What is the magnitude here? The 1. And 1 to 2, the magnitude is a negative value, the minus 2. And 2 to 4, it is a positive value with the magnitude of 2 here. Is a minus 2, and 1. 2 to 4 is a 2. And the 4 to 5 is also minus 2. The remaining is a zeros. So write all the terms, 1, 2, 3, 4, 5 terms is there. From 0 to 1, e power minus st dt is the magnitude is a 1. And 1 to 2, the magnitude is a minus 2, e power minus st dt. And 2 to 4, the magnitude is t, e power minus st dt. And 4 to 5, the magnitude is minus 2, e power minus st dt. Apply the integrals. E power minus st is e power minus st by minus s, 1, 0, 2, 1, 4, 2, 5, 4. But all the terms, e power minus s by minus s, and lower limit is apply. E power 0 is the 1 plus 1 by s. For the second one, upper limit is a square. 2 into e power minus 2s by s, because a minus into minus is a plus. And for the lower limit, minus term is there, e power minus s by s. And 2 into, here the minus is there, e power minus 4s by s. And lower limit will get the minus and minus in plus. 2 into e power minus 2s by 2 by s. And for this, there is another two terms, minus into minus is a plus. E power minus 5s by s and e power minus 4s by s. Okay. All the terms we have, see the 1 by s is a common. 1 by s. So 1 by s is a 1 minus 2 into e power minus 2s by s. Because these two get cancelled, e power minus 2s. E power minus s by s is a 2 e power minus s. For these two functions, will get as minus 2s, 2 into e power minus s. Okay. And another one is there, e power minus 2s by s, and here the minus 2 e power 2s by s. Totally is a 4 e power minus 2s. Okay. Then e power 4s, and here the e power 4s is there. Here minus 2, it becomes of minus 4s for these two. And only one term is remaining is there, the 2 e power minus 5s. Okay, finally we'll get 1 by s into, for this function 1 by s, and for this function combining of these three, 2 into e power minus s, 4 into e power minus 2s, minus 4 into e power minus 4s, plus 2 into e power 5s. Got it, minus 2s. For any given graphical representation, first of all, you can write the equations, mathematical equation, then you can apply the definition of the Laplace transformation. What we did here, it is a x1, y1, you can take this first of all, and x2, y2 for this one. For this slope, you can take this as a x1, y1, and this one is a x2, y2. Got it, my students? To get the slope of this one and to get the slope of this. From here, the s1 and s2. Okay. Then determine the Laplace transformation of the periodic sphere wave. So simple, you can find out up to the 0 to t. Then apply the one of the property, we have the periodicity property, 1 by e power minus s t into x1 of s. Okay, what is the 0 to t here? So according to the periodicity property, x of t plus t, the Laplace transformation is 1 by 1 minus e power minus st into x of s. Okay, the signal, it is a periodic function. You can find out the Laplace transformation and multiply with 1 by e power minus st. Simple. So what is the periodic signal here? The periodic signal is up to the 0 to t, and it is repeated again and again for every interval of the t. So for 0 to t, not the 0 to t, 0 to the some value is here, positive a and the minus a is there. 0 to t, the range is plus a and minus a, plus a and minus a. Okay. See, x1 of t is 0 to t by 2, the plus a, and t by 2, the t is a minus a. Take the 0 to t, directly can substitute in the definition of the Laplace transformation. That Laplace transformation saying that it is a 1, 0 to t by 2, 0 to t by 2 a into e power minus st dt plus integral t by 2 the t, that is a minus a into e power minus st dt. Got it, my students? Within hand, you can multiply with 1 by e power minus st. This is only for the x of s. So e power minus st by minus s, with upper limit is t by 2 and lower limit is a 0, and a is multiplied here, and then minus a into e power minus st by minus s, with upper limit is t and lower limit is a t by 2. Now we can simplify. Now we get the simplification, we get a by minus s. I'm taking t by 2, so e power minus s t by 2 minus 1. Why it is a minus 1, e power 0 is a 1. And the minus a by, and I'm taking the minus s, it becomes as a plus s. First I'm substituting the e power, this is a small t, minus s into t, minus e power minus s into t by 2. Got it, my students? T by 2 here. So a by s minus e power minus st, and the a by s, it is also minus a minus st. A by minus 2 by as into e power minus st by 2, my students. For these two functions, minus, not the minus, plus a by s plus a by s into e power minus st. Now it is in the form of a simple function. It is in the form of the a by s, you can take the common. A by s is a common, 1 e power minus st and minus 2a by 2. This is a whole square, simple. Take if I am taking the a by s is a common term in all the terms, 1 plus e power minus st and minus 2 e power minus st by 2. 2 e power minus st by 2. Take this a, and this one is a square of the terms. Square of the term is a t by 2. Write this function as 1 by s 1 square plus e power minus st by 2 whole square minus 2 into 1 e power minus s by 2. So it's in the form of a square plus b square minus 2ab. So a by s into 1 minus e power minus st by 2 whole square, simple function, whole square. Got it, my dear students? And it is multiplied with 1 minus e power minus st. 1 minus e power minus st. A by s into 1 minus e power minus st by 2 whole square it is there. Got it? And it is multiplied with 1 minus e power minus st because it is a periodic function, my dear students. And this 1 minus e power minus st can write as a plus b into a minus b. Taking off t by 2 here. 1 minus e power minus st by 2 plus 1 minus e power minus st by 2. And this one square term and this get cancelled. Don't confuse, my dear students. This is a square and here the square. A square minus b square is a plus b into a minus b. When if you are writing the a square here, the t by 2 whole square you can write. And minus term is one of the square. This is a square, it get cancelled, and minus term is get cancelled. A by s into 1 minus e power minus st by 2 by 1 plus e power minus st by the 2. Got it? Okay, my dear students. Then initial value and final value we already seen. We already discussed about that one. What is the initial value? T tends to 0 and s tends to infinite. Final value is t tends to infinite and s tends to 0. Both are the same. Not the same. Remember that it is x of t, limit t tends to 0, x of t is equal to limit s tends to infinite, s into x of s. The same functions you can write, but by changing the limitations, I'm saying that same signals, limitations is changed. The finite value is the limit t tends to infinite to limit s tends to 0. But to prove these two, initial value and the final value, you can take it as a differentiation property of a unilateral Laplace transformation. In that unilateral Laplace transformation only, we'll get the second term is there, x of 0 minus or 0 plus, or it is a 0 simply also. Got it? And remaining examples we have, we can discuss in the next class with the inverse Laplace transformation also. Any doubts? Okay, thank you.